So now that you have your unit circle, we can do a bunch of questions, mental math. Okay? And the way that we're going to think about this is you're going to have quadrant 1 memorized the best. So as soon as I see 7 pi over 6, I know that my reference angle, that's part of my pi over 6 family. Sine is the y-coordinate. The y-coordinate of pi over 6 is a half. So I will know that sine of 7 pi over 6 is also a half, but because it's in quadrant 3, and my cast rule in quadrant 3 says that sine is negative, or you can just think about the y-coordinate being negative, because sine is your y-coordinate, I know that sine of 7 pi over 6 is negative a half. Okay? This part might all happen in your head. And you just write negative a half down. Or on the exam, they give you a little blank unit circle. Maybe you quickly draw out quadrant 1 or more of it, and you have it like a little mini pie plate that you're allowed to use on your exam. But you have to have it memorized when you walk in, but the first thing you can do is fill that out. So I see sine of 7 pi over 6. I immediately think, I know that's part of the pi over 6 family. I know that sine of pi over 6 is a half. I know this is in quadrant 3, and sine is negative in quadrant 3, so it's negative a half. Yes? Well, that's one of the ones on my unit circle. Notice that it's one more than the denominator. That was a strategy that we used to memorize our angles in quadrant 3. So again, doing that worksheet that I gave you last class, you just need lots of practice with all of these radian angles. So you start to get comfortable with, oh, 7 pi over 6 is on my pie plate. It's in quadrant 3. And after you do your quiz tomorrow, you'll probably be even better at it, because you'll have to study tonight. Tan of 2 pi over 3. So I know that tan of my pi over 3 is root 3. So off over here, I'm thinking reference angle pi over 3. Quadrant 2, cast rule says that will be negative. Negative square root of 3. So again, I'm thinking back to here. I know that tan of pi over 3 is root 3. And because it's over here in quadrant 2, it's going to be negative. So I'll give a little pause at the beginning. I want you to think of reference angle and which quadrant it's in. Okay? Pi over 4 family. You see how easy reference angles are in radians? Okay? Quadrant 4. So it's going to be root 2 over 2, and it's going to stay positive. Secant. No, it's cos. So secant, it's reciprocal of secant is cos. So off to the side here, this is what you're going to think about. You're going to think about cos first. You're going to always think of your primary ones first. What's your reference angle? That's easy. It's pi over 4. What quadrant is this one in? Okay, you'd have to think about negative pi over 4 going in this direction. It's going to be in quadrant 4. And then it will equal root 2 over 2. So then over here, right, positive because it's in quadrant 4. Then for secant, you would get 2 over root 2. So the angles don't change. Notice that we use the same angles, but the answer is the reciprocal. It is if it's positive angle. But this is a negative angle, so it's going the opposite direction. pi over 4 is normally in quadrant 1, right? So if I have negative pi over 4, it's like this is my first negative quadrant. So that's often how I think of negative angles. I think of positive angles going around one way, and negative angles I just do the opposite. Like, oh, if I have negative 5 pi over 4, well, 5 pi over 4 is in the third positive quadrant, so negative 5 pi over 4 would be in quadrant 2 because that's the third negative quadrant. Yes? 6.1 to 3, it's actually after we have this quiz, we finish our unit circle stuff, and then we have that quiz. It's coming. But we're going to finish this extra notes, then go back and do those questions that we skipped, because we left 2A and 6.2 and 2A and 6.3. We'll finish those up, and then we'll have our 6.1 to 6.3 quiz. Cotangent, negative 11 pi over 6. So again, I would start by thinking of tan of negative 11 pi over 6. Reference angle, really easy to figure out. Pi over 6. We have to figure out what quadrant negative 11 pi over 6 is. It's going to be quadrant 1, because 11 pi over 6 would, in positive angles, is quadrant 4. So can you see that I've gone 1, 2, 3, 4 quadrants in the negative direction? Okay? So I think positively. It's always good to think positively. And then work in the other direction to realize that's in quadrant 1. And now I just think about quadrant 1. What is tan of pi over 6 in quadrant 1? It's root 3 over 3. So cotangent will be 3 over root 3. Okay? Again, you do not have to rationalize the denominator in grade 12. If they ask you for the answer and leave a square root on the bottom, that's fine. If this was in a multiple choice, the multiple choice would have root 3 as the answer. Okay? So two things. You could either rationalize this denominator, or you might remember from our special triangle that we had originally had 1 over square root of 3. And we had rationalized the denominator early. But had I kept 1 over the square root of 3, the reciprocal would be square root of 3 over 1. Same thing in the previous question, right? Originally on our unit circle, we had written that as 1 over root 2. This one, on a multiple choice, they would write it as the square root of 2. So sometimes on multiple choice, you come up with an answer and you're like, my answer's not there. Did I do something wrong? Maybe not. Maybe they have the same answer in a different format. Okay? And on multiple choice questions, they're usually following all the simplification rules, like you can't have a square root on the bottom, so that would have been fixed up. Cosecant of negative pi over 2. So you would think of sine of negative pi over 2. Can you see that pi over 2 is part of your axes family? Okay? Here's your unit circle. Can you see that negative pi over 2 would be right there? For your axes family, it's really easy to think about your coordinates. Because it's a unit circle, does it make sense that this is 0, negative 1? And so what is sine? Which coordinate is sine? The x or the y? It's the y. So it's going to equal negative 1. We don't really have to say a quadrant here. I mean, the reference angle is pi over 2. But it's in between quadrant 3 and 4. It's really not in either one of those quadrants. Or it's in both of them, depending on how you want to think about it. So then sine of negative pi over 2 is negative 1. Cosecant will be 1 over negative 1, which is still equal to -1. All right. If you want to say, what kind of question do they love to put on the exam over and over again? And you remember things when you put asterisks beside them, 5 of them. 5, oh, this is super important, 5 asterisk questions. Yes. This is a favorite 3-mark question on the exam. What is it? It is combining unit circle, reciprocal functions, coterminal angles, all together with a little bit of multiplication or arithmetic. So you have to figure out each of these separately, just like we did in these previous questions. These previous ones, you did tan of 2 pi over 3, right? We did secant of negative pi over 4. So we can figure out each of these individually. And when figuring them out individually, you're going to use your skills with the unit circle and that locating angle sheet that I handed out to you yesterday. So off to the side, I'm going to separate my paper because I'm going to do work off to the side. Maybe on an exam you would do this on scrap paper. And you're going to figure out each of these separately. So I'm going to start with secant of 11 pi over 3. But in order to figure that one out, I'm going to need to do cos of 11 pi over 3. Now my reference angle is easy. It's pi over 3. My quadrant, this is where on that locating angle sheet and what we did yesterday, or sorry, on Friday, is we would take a big angle like 11 pi over 3. We would change it to a mixed fraction to 3 2/3, and now I know it's in quadrant 4. As soon as I change it to a mixed fraction, it tells me what quadrant it is in quickly. Again, a review. How did I tell that that was quadrant 4 so quickly? Well, 3 is the whole number. That would mean 1 pi, 2 pi, 3 pi, I would end on the negative x-axis. And then my fraction, which is 2/3, is more than a half, would end in quadrant 4. So I know that it's in quadrant 4. Therefore, cos of pi over 3 is equal to positive 1/2. I know from quadrant 1, cos of pi over 3 is a half. And since it's in quadrant 4, it's going to be positive because cos is positive in quadrant 4. Can you see yourself? Whew, I need to practice this a fair bit, right? Because I know that I've obviously practiced it a lot, that I can just quickly say which quadrant and stuff. But that's why those questions, I'm going to tell you, this is something you need to practice lots because you're going to get a question like this on your exam. So then secant of 11 pi over 3 is equal to 2 over 1. And we can go in our question, we've now figured out the first one is 2 over 1. Go back to my scrap paper. Go to the second one, cos of negative 5 pi over 4. Easy to see the reference angle, right? Reference angle, pi over 4. What quadrant is it in? If it was positive 5 pi over 4, it would be in quadrant 3. It's negative 5 pi over 4. Quadrant 2. Again, Since 5 pi over 4 is on your pie plate in quadrant 3, I just thought in the negative direction, 1, 2, 3 quadrants would be quadrant 2. If you wanted to change 5 pi over 4 to a mixed fraction, can you see that it's 1 1/4 pi? And if I go negative 1 1/4, negative 1 would be here. A quarter is less than half. It has to end in quadrant 2. Now that I know that it's in quadrant 2, cos is root 2 over 2. In quadrant 2, cos is negative. So then all of that work off to the side, and all you need to do is write down the number. Okay, erase this. Our last one, tan of 23 pi over 6. First of all, my reference angle's easy to tell that it's pi over 6. 23 pi over 6 as a mixed fraction is 3 5/6 pi. What quadrant is that in? Close. It's in quadrant 4, right? Because 3, 1, 2, 3 would end you at the negative x-axis. Then 5, 6 is more than a half. It's going to end in quadrant 4. And so since we know that it's in quadrant 4, okay, tan of pi over 6. See why I like this, that strategy I told you before about memorizing, that 6, 3 plus 3 is 6. So that lets me remember that this is going to be root 3 over 3. And because it's in quadrant 4, it's going to be negative. So now I can fill this one in. And our final step is just going back to like fractions from grade 7, 8, and 9. How do you multiply fractions? You multiply the top, you multiply the bottom. So on the bottom, let's do that first because it's nicer numbers. 1 times 2 times 3, 6. On the top, negative times negative will make it positive. We'll get 2. How do I multiply square root of 2 times square root of 3? Square root of 6. So you could leave your answer like this. If you simplified it, this is how it would be on a multiple choice question. Square root of 6 over 3, because the 6 and the 2 could be simplified. That would be your final answer. So these ones with the 5 asterisks, I have given you, I think, maybe 30 practice ones. I'll count them. On the first practice sheet that I gave you, that was really small numbers. Okay. Part 1 was just stuff on your unit circle. Part 2 was stuff on your unit circle with coterminal angles. But part 3 and part 4, which is only 10, no, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 questions like this one. It was an assignment sheet that you picked up after we did, I think after you filled out your unit circles. Anybody else not have this paper? Okay. Next thing we look at is solving. Now we can solve trig equations that we couldn't before. Well, we could before, but we had needed our calculator before. Now we're going to do them without our calculator. So, if this was grade 10 math. Just a review, because you still need to know how to do grade 10 math. Okay? If I was solving this in grade 10, first of all, grade 10 or 11, it would be in degrees. Notice this one's in radians. In grade 10, if you had sine of theta equals negative root 3 over 2, you would go to your calculator and do sine inverse of negative root 3 over 2. Well, in grade 10 and 11, you would still do sine inverse of positive root 3 over 2 and find your reference angle first. This is probably more like grade 11. Grade 10, you didn't do all 4 quadrants. Grade 11, you did. Okay? So we remember that when we do our reference angle, we always think positively. You would have gone to your calculator in grade 11, waited for it to turn on, and done sine inverse of root 3 over 2. Okay? Your calculator would have told you that your reference angle is 60 degrees. So let's make sure. My mode, I'm going to switch to degrees because we're back in grade 11. Okay? Do sine inverse of the square root of 3 divided by 2. And sure enough, my calculator tells me my reference angle is 60 degrees. Now that I know my reference angle is 60 degrees, I would have used my cast rule in grade 11 to say that sine is negative in quadrants 3 and quadrants 4. And so 180 plus 60 would give me 240 degrees, and 360 minus 60 would give me 300 degrees. There's grade 10 and 11. That's how we did things before. We always used our calculator. Now, in grade 12, this shows up on a non-calculator part of the test, and it's in radians. So the way that we look at it is we say, is root 3 over 2 ever our y-coordinate on our unit circle? Yes. What family? That's our pi over 3 family, or our 60-degree family, right? So on our calculator, it came up as 60 degrees. That's pi over 3. And then, when is sine negative? Quadrants 3 and 4. What's your pi over 3 family in quadrant 3? 4 pi over 3. What's your pi over 3 in quadrant 4? 5 pi over 3. That's all the work we would show when we solve the question without our calculator, without having to draw any triangles. I mean, you're still allowed to draw the triangles if you want. You can still draw, you can still say, I know it's in quadrant 3, make a triangle back to my nearest x-axis. Here's my reference angle of pi over 3. And that way, I know that I can draw it that way, but we can just figure out our angles directly. So, cos, that's your x-coordinate. Is your x-coordinate ever equal to negative 1? When? What angle? Again, yeah, it's at pi. Done. That's all the work you need to show. Okay? The x-coordinate's only negative 1 once, only at pi. This is on an axis family. Don't need to do any work with reference angles for your axis family. Right? Because you've got unit circle. Here's your point, negative 1 comma 0. And the angle's pi. Okay? Again, it's really important that you double check your domain. Your domain is from 0 to 2 pi. That's once around in the positive direction. Tan is equal to negative 1. And the reference angle is pi over 4. Right? So again, just thinking quadrant 1, when is it equal to 1? Pi over 4. What what quadrants is tan negative? Quadrant 2, so that would be 3 pi over 4. Quadrant 4, that would be 7 pi over 4. And you want to get yourself to that, I'll say, fluency, that quickness, that you can just say, you can just rattle off, pick a family, quadrant 3, quadrant 4, I know which ones are there. Quadrant 2, quadrant 3, I know which ones are there. So we need to do a lot of just practice. Those sheets that I gave you, you need to practice them just because your brain needs to start getting used to working with radians and being able to quickly say, hey, pi over 4, quadrant 2, that's 3 pi over 4. Quadrant 4, that's 7 pi over 4. Get a secant question. Whenever you get one of the reciprocal ones, you are going to first change it to one of the regular ones. If secant is equal to 2, then cos of theta would equal 1 over 2. What family has 1/2 as the x-coordinate? No, 180, it's at -1. Pi over 3. I have some people say that the most important one that they memorize in quadrant 1 is sine, well, I'll write the angle. They memorize sine of pi over 6 is 1/2. They say that's the most important one because then if I have cos is 1/2, then I know it's the pi over 3 because I know those ones switch. Now that I know that it's pi over 3, when is cos positive? In quadrant 1, so that'll be pi over 3, and quadrant 4. How many people use the double subtract 1 in quadrant 4? Double the denominator, subtract 1 to get 5 pi over 3. Could get a solving question where you have to do a little bit of algebra to begin with. So if I want to solve for sine of theta, or if I want to solve for theta, I first need to get sine of theta by itself. What does that look like? -1/2. So again, reference angle. When do we have 1/2 for sine? Pi over 6. So if that's the key one that you've memorized, sine of pi over 6 is 1/2. This one's super easy. What quadrants is sine negative in? Quadrant 3, 1 more than your denominator. Quadrant 4, double -1 for your numerator. Next level. We'll make our connection between, this is where I said this unit, I teach you one little thing, like your unit circle. And now we can say, let's connect it to everything you've learned in the past and add all new questions. So for example, you know how to solve quadratic equations from grade 11. Right? Like if this was just x's, x squared minus x equals 0. How did you solve that in grade 11? Here's our little grade 11 review. How would you solve that one in grade 11? Well, you'd be, oh, I can factor. There's a common factor in both of those. When we factor something in grade 11, we always made one side equal to 0. The reason for that is that when you factor, you change from adding and subtracting to multiplying. And if I tell you to multiply two numbers and the answer is 0, one of the numbers had to be 0. Does that make sense? And so when you factor, the reason we factor is because we could say, well, one of these two numbers has to be 0. If it was the first number, and we often draw a line to separate the two numbers, if the first number is 0, well, then x would have to be 0. If my second number is 0, well, then x would have to be 1. And that's how we would solve that equation in grade 11. We would factor it and find out what are the values that work. Now in grade 12, the only connection is we're now doing it with trig functions. Can you see that these two things are identical, except instead of having x squared, we have cos squared. And so there I factored out a common factor of x. Here, I'm going to factor out a common factor of cos. I would split it and say now that I'm multiplying to equal 0, either this one's equal to 0. Well, does it make sense then cos theta would equal 0? Or this one's equal to 0, in which case cos of theta would equal to 1. And up till this point, it's been identical to grade 11 solving. Just instead of an x, you're using cos. But now we still need to solve for theta. Do you ever have your x coordinate at 0? Yes, that's on your axes family. At pi over 2 and 3 pi over 2. Do we ever have our x coordinate at 1? When does that happen? At 0. And also if you went around at 2 pi, notice that in our domain, 0 is included and 2 pi is included. So we would include both 0 and 2 pi. Your textbook sometimes likes to do this. What's the difference? Then the 2 pi is not included. And so if you wrote down 2 pi, then it would give them the right to take off a half a mark for an answer outside of the domain. So this idea that I keep saying over and over again, reread your question once you're done, okay? Like, that's a very tiny little difference, whether that little line is under that equal sign or it's not. And if you don't notice that difference on the exam, it's a half mark deduction. So we are often rereading our question, looking for those little details. So currently, you might have to think back to grade 11 quite a bit. You might have to think, okay, here I have sine squared minus 3 over 4 equals 0. If I had in algebra something squared minus 3 over 4 equals 0, what were my algebra steps to solve for x? Okay, this one's different than last time. Last time you had a common factor. This time we just have one x squared. Would you get x squared by itself? And then that would allow you to square root both sides. What do you have to remember when you square root both sides? Plus or minus. And then in grade 11, you would have had to simplify this. Square root of 3. On the bottom, you'd have square root of 4, which is just positive 2. So there's your grade 11, okay? In grade 12, you wouldn't show this extra work. This would just be in your head. It's like I know how to solve in grade 11, so now in grade 12, I would do the same things, but just with sine squared. I'd move my 3/4 over. I'd square root both sides, and remember the plus or minus. And I'd simplify and get sine of theta is plus or minus root 3 over 2. Is root 3 over 2 on your unit circle? Yes. What family gives you that in quadrant 1? Pi over 3. Again, if you've memorized this one, if that's the one you've memorized, when you see root 3 over 2, you're like, oh, it's not pi over 6. It's pi over 3. Well, root 2 over 2, that's just so easy at pi over 4, because they're both the same. Maybe. It takes some practice. So I've got my reference angle at pi over 3. It's positive and negative. And so I'm going to have all 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4 for my answer. This is like a family gathering. Everybody's there. All right, we have about 5 minutes left. If you have that sheet from the other day where you were the multiplying ones, I'd like you to work on that right now. We'll finish up these other questions in period 3.